In our 9091 folder, we want to go to our Unit 2 notes that we've been working on. And this is going to be the last thing that we're going to do before our Unit 2 exam. So, whoops, that's the wrong one. We don't want the parent functions. We want the Unit 2 notes. All right. I'm going to do absolute value inequalities in just a moment. But let me back up a little bit. The last thing that we did were the absolute value equations, like we just did on our Kahoot. And the idea being that you want to get the absolute value by itself, which we did here. And then you write two equations. You do the 5 plus 4x equals -9. And then you do the 5 plus 4x equals +9. And then solve both of those. And then don't forget to check them, because we sometimes get extraneous solutions when it comes to absolute values. Backing up even more, before then we were doing radical equations. Similar process, get the radical by itself, square both sides, check your answers. Solve and check your answers, okay? And then backing up even more, that's when we were doing all the quadratic stuff, completing the square, finding the vertex, writing things in vertex form, all of those things. All right, so remember that absolute value, like we talked about in our last class, absolute value means distance from zero. And if you can remember that it means a distance, then hopefully the absolute value inequalities make a little bit of sense here. For example, I'm going to do problem B first. Just to read what this question means, that is that we want the stuff that is inside of the absolute value to be more than or greater than or equal to 5 units away from 0. Okay, again, this stuff that is inside the absolute value, we want it to be more than 5 units away from 0. So here's how I'd like you to think of it. And you don't always have to write this out, but if you could visualize in your head a number line and think, okay, here's 0, and 5 units away from 0. If I go 5 units to the left, that would be at -5. And if I went 5 units to the right, this would be +5. And again, you don't have to write this out, but this would be how you would visualize how to do this problem. We want this 2x minus 3. Okay, so let's imagine we didn't know it was 2x minus 3. Whatever's underneath that black blob, we want that to be here, or we want it to be over here, because those black blobs are more than 5 units away from 0. Well, remember, the stuff that is inside there is 2x minus 3. So we're going to write two equations and then solve them. When we write our two equations over here, that means the 2x minus 3 has to be to the left of or less than -5. That's one of our equations. 2x minus 3 is less than or equal to -5. I did the equal to because of that. So this gave us this equation. On the right side, the 2x minus 3 has to be to the right of or bigger than +5. So 2x minus 3 would be greater than or equal to +5. So this visualization yields that equation. And so now we want to solve the two green equations. And so when we solve that, these are just our regular, inequalities. So I'll move the 3 over. I get 2x is less than or equal to -2. X is less than or equal to -1. Here I have 2x is greater than or equal to 8, or x is greater than or equal to 4. So our answer could be either here or here. It's an or statement because we have two regions, two different regions. It could be in one region or the other region. So written in interval notation, this, all numbers less than -1, written in interval notation is from negative infinity to -1, inclusive because it's less than or equal to. And union, all numbers greater than or equal to 4 would be from 4, comma, to infinity. So that would be our final answer.
Do we need to write it like that, or can we just leave it the x? X is less than -1 and x is greater than 4.
Yeah, you should get in the habit of writing it in interval notation. When you do your homework, Delta Math will accept either one of these. Remember, it is an or statement, though, as opposed to an and statement. We'll do one of those in just a minute.
Okay.
Okay. All right, let's do another one. So for part A, all right, this stuff underneath the black blob, we want that less than 2 units away from 0. So this is how you would visualize. You don't have to write this out every time when you get used to them, but hopefully it's helping as we start. Here's 0. Here's 2 units to the right. And here's 2 units to the left. And we need the stuff inside the absolute value to be less than 2 units away. So we need that stuff to be here, because that's less than 2 units going to the left. And there, that's less than 2 units going to the right.
Wait, why is it there when last time it was on outs like?
So the difference is last time this was a greater than, meaning we wanted distance more than that away. So
Okay.
if you went further from 0, you got to go further away. This means less than, so we want distances less than 2 units away. Okay? So yeah, you have to be really careful of that sign. And so x minus 5 is what is underneath the blob. So this part means that x minus 5 has to be to the right of -2, meaning greater than -2. So my first equation would be x minus 5 is greater than -2. That is from that side there. My second equation, x minus 5, has to be to the left of +2, meaning less than +2. So x minus 5 is less than +2. And so when I solve these, I get x is greater than 3 and x is less than 7. Now, another difference between this less than as opposed to greater than is this is really all one region that's less than 2 units away from 0. You know, it's all one region. So that makes it an and statement. Your solutions are all numbers that are greater than 3 and less than 7. So in interval notation, it would be everything from 3 to 7, exclusive of both of them. All right, any questions on those two?
Are we supposed to use brackets or parentheses? Like, it's supposed to be parentheses?
This case would be parentheses because not equal to. There's no equal sign there.
Okay.
As opposed to this one, which were brackets at the boundary points, because we do want to keep the points that are equal to. Okay? Anything else? All right, well, let's keep rolling here then. So to do this one down at the bottom, to part C, we're going to do the same thing, but we just got to get the absolute value by itself first. So I'll add 2 to both sides. So I get 4 times the absolute value of x plus 3. It's greater than 12. And so I get the absolute value of x plus 3 is greater than 3. So looking at this, it's real similar. We want distances. We want this stuff to be more than 3 units from 0. So when it's more than or greater than, that means you're going to have 2 regions, much like this situation up here, which makes it an or statement, as opposed to a less than symbol, which means you're only going to have 1 region, making it an and statement. So how I want to visualize this is I want my stuff underneath the absolute value, so this stuff, to be more than 3 units from 0. So that means that that blob has to be over here. That's more than 3 units to the left. And, or I should say, I'm sorry, over here, that will be more than 3 units to the right. So x plus 3 should be less than -3, or x plus 3 should be greater than +3. Those are going to be my 2 equations that I will solve to give us our solution set. So let me write those again. Over here, x plus 3 is less than -3. And over here, x plus 3 is greater than +3. Okay, and I'm going to even write here that it's an or statement because we have 2 regions, this region and this region. It could be a one or the other. So here I have x is less than -6 or x is greater than 0. So in interval notation, that's going to be everything from -∞ to -6, exclusive of -6 because not equal to, union from 0 to infinity. So that occasion where we had 2 sections there, that was an or statement, much like part B. So we could have one side or the other. It could be in one region or the other. As opposed to part A, which only had one section or one region where your answers were. So that means it has to satisfy one and the other. That is an and statement. All right, let me try one more. And then there is another way that we can plug in some answers to check them that I'll show you at the end. But let's do this problem down here, part D. And the first thing we need to do in part D is to get the absolute value stuff by itself first. So I'm going to subtract the 8 over to the other side. So I get the absolute value of 6x minus 13 is less than or equal to -1. All right, so for those of you that are wondering, wait a second, is it an and statement if we have a less than symbol, and is it an or statement if we have a greater than symbol? Oftentimes, yes, but always is a tricky word in math. Because if you really are understanding conceptually what's going on here, then you may be ultra confused as to what's happening in this problem. Because this problem is stating that we want this stuff to have a distance less than or equal to -1. But remember, we said distances are always positive. You can't have a distance less than or equal to -1. That is impossible. Therefore, there's no solutions. To that one. And again, there's no solutions because you can't have a distance less than -1.
Wait, so what if the sign was flipped? So if it was 6x minus, like the absolute value of 6x minus 13, that's greater than 7.
That question is spot on. That means you are totally getting it that you're asking that question. If we had the absolute value of 6x minus 13 is greater than -1, sorry, or greater than or equal to, it doesn't matter. Let's think this through. Let's think about what that statement is asking. That's saying, give me distances that are greater than -1. Well, we just said distances are always positive, right? And since distances are always positive, they're always greater than -1. Therefore, all real numbers works here. Anything you plug in, that statement is going to be true. You plug in any real number you want, that will be a true statement. Because this side's always going to be a positive, it's always going to be greater than -1. Just like going back to the red one, you can't plug in any numbers to make that true because this is always going to be positive. That can't be less than -1. It's always going to be positive. It can't be less than that. It's impossible.
I have a question.
Yeah.
So if So if the problem asked us to like divide by a negative number or to multiply by a negative number, doesn't that mean we have to flip the inequality?
You would have to flip the inequality. Yes, good question. Yeah, just like you always do for any other inequality. All right, these are really good questions. I mean, you guys are certainly thinking this through here. Now, one last thing is there is a way to check your answers. And when we come up with x is greater than 3 and less than 7, so 3 and 7 are boundary points. You know, you can think of a number line, and here's 3 and here's 7. And so we have, if the number line is split up by 3 and 7, we have 3 different regions here. We have this region, we have this region, and we have this region. Well, if I pick a number in the circular region like 0, and I plug 0 into here, 0 minus 5 is negative 5. I almost said negative 3. Is negative 5. The absolute value of that is positive 5. That is not less than 2. So 0 like doesn't work. So what that means is that in this region over here, that number did not work. If you choose a number between 3 and 7 in that middle region, like 5, and I plug 5 into the original, 5 minus 5 is 0, absolute value of 0, which is less than negative 2. So 5 does work. So looking down here, this region does work. And then if I pick another one in this right region, you know, like 10, and I plug that into the original. Now 10 minus 5 is 5. The absolute value is still 5. That is not less than 2. So that did not work. Therefore, that region does not work. And so the only region that worked for us was between 3 and 7, which is what our solution was. So you can also use these boundary points at the end to check and see if you are getting the correct answers. But this is our solution. That is our solution set, or our answers. So how about if I give you guys 2 problems to do, and I'll just write them, I'll just write them right down here, and then we'll go over them together in just a minute, just as kind of a little quick check to see if we're doing okay here. All right, would you guys write these down, please, underneath your notes? So let's say we have 4 plus the absolute value of x minus 3 is greater than 10. That will be our first problem. Our second problem will be 2 times the absolute value of x minus 4 is less than or equal to 20. All right, how about if you guys try those 2 problems, take a couple of minutes to do them, and we'll go over them together in, let's say, 5 minutes at 3:08. All right, let's take a look at these couple of problems together. So the first one here, I'm going to move the 4 over. So I have the absolute value of x minus 3 is greater than 6. Okay, subtracted 4 from both sides. Now I do my visualization, and I say that I'm writing it out, but you guys don't have to. I want distances more than 6 units away from 0. So here's 0, here's -6 to the left, here's +6 to the right. So if I want this to be more than 6 units to the left, I can't seem to grab it here. It would be over there. And if I want this to be more than 6 units to the right, it would be over there. So I need my x minus 3 to be less than -6 because it has to be to the left of -6. And I need my x minus 3 to be greater than +6 because it has to be to the right of +6.
Mr. O'Connor, I have a question.
Yes.
Where do you get like to the left, like less than -6? I'm just confused about that part.
Okay, do you get that we need it to be more than 6 units away, so it has to be to the left of -6? Is that what you're
I'm just
confused?
confused why you go negative as one of the solutions.
Yeah, well, because absolute value means distances, okay? So think about it as walking. This is saying you want to walk 6 paces away from 0, but you can walk in both directions. If you walk 6 paces away going to the right, you're going to end up there. If you walk 6 paces away to the left, you're going to end up there.
Yeah, I'm just confused though because like absolute 0 x minus 3 is greater than 6. So why would you go to the left?
Yeah, because you
and
want
then
to
go
walk.
negative.
Yep, because you want to walk more than 6 steps away from 0. So I'd have to go like 1, 2, 3, 4, 5, 6, 7, 8, 9 steps away. So if I keep going, if I keep stepping that way, I'm moving to the left of -6 as I'm visualizing it, as I'm looking at it, and meaning less than -6. Like -9, if I went to -9, which is, or -10, which is way out here, if I went to -10, that would be, 10 steps to get out there. That would be more than 6 units away. So I want it to be to the left of -6 because that puts me more than 6 units away from 0. All right, I'm hoping that helps. I know this is a little tricky, takes some time. All right, so I'm going to keep rolling with this equation here. I have x minus 3 has to be less than -6, or x minus 3 has to be greater than +6. And the reason it's an or statement is because I have 2 different places, 2 different regions for my answers. And so x is less than -3, or x is greater than 9. In interval notation, that is from -infinity to -3, exclusive, and then exclusive of 9 to infinity.
I have a quick question.
Yeah.
So if we look at example A that we did,
Yep.
does it matter which like in which order you do it? Like could it be 7, 3, 3, 7? Like does it matter?
It does. It always has to be smallest to largest. Since 3 is smaller, that has to be on the left. Interval.
Oh, okay.
Yeah, it's always smallest to largest.
So like left to right.
Correct. Left or right. All right, let's do this last one here. So I will divide both sides by 2. So I have the absolute value of x minus 4 is less than or equal to 10. And so now I want my distances less than 10. So like 9, 8, 7, or -9, -8, -7. So less than 10 units away from 0. So this is 10 units to the right. This is 10 units to the left. And that x minus 4 has to be somewhere in there. Okay, it can be here. It can be here. It has to be less than 10 units away from 0. So my two equations is that x minus 4 has to be greater than -10, or equal to, I should say, greater than or equal to -10 from here. And x minus 4 would be less than or equal to +10. I'll solve both of those. So I get x is greater than or equal to -6. And x is less than or equal to 14. And so in interval notation, that is bracket -6 to 14 bracket. All right, we had great questions today. Is there anything else before I let you guys try some more on your own on Delta Math?